the midterm, like maybe like 2 weeks from now. Just ask.
Wow. Hello, everyone. Sorry about that. My virus checker insisted that I reboot my computer, so I did. So here we are. So let me get everything open here. Yeah, when the virus checker says something like that, you do it. I don't know. It was just basically saying that it couldn't update itself or something. I wasn't sure what it meant. So I said, go ahead. But let us carry on. Now, today we're going to do the sample midterm. Okay. Now, the sample midterm is meant to be a very good reflection of what's on the actual midterm. If you can do this, you can do the actual test. Okay. So remember, this is the first 3 chapters only. And so there's a little bit of everything here. It'll take you back all the way to the beginning of September, actually the end of August, I should say. And but if you look at it carefully, you'll see that there's nothing here that's the least bit surprising. You might have to double check your notes for some of these, especially the fill-ins, the short answers. But basically, it should be fine. I mean, as long as you've been following along, you should have absolutely no difficulty at all in doing these questions. All right, so why don't we start here? First of all, let me save this. Okay. Today's the 13th. Yes, I very nearly forgot to send out the invitations too. It wasn't my day yesterday, but I remembered it at the very last second. And so I guess you got them, otherwise you wouldn't be here. But you know how I always like to have them out at least a day ahead, but didn't quite happen, did it? So, but anyway, here we are. So we'll start with the interesting question, the slope of a vertical line. Now you can memorize this one, or you can try to reason it out. Let's take a look at a vertical line and try to calculate its slope. All right. So a vertical line would look, oh, wait a minute, hold on a second. I just realized my tablet is not plugged in. Yes, Fernando.
Good morning, Professor. I have a quick question to ask.
Yes, go ahead.
Just wanted to ask if you could remind, I guess if you could remind us, like, when is the due date of like when we take the midterm again? Just to be more.
Oh, it would be a week from today at midnight. So in other words, the 20th at midnight. So if you want, I can put an announcement in the Moodle just to be on the safe side. So in fact, why don't I do that right now? So just as a precaution, let's go to Moodle. Oh, what is it doing here? There we go. So let's go to Moodle. And we will, yes, because it has the capability of making announcements. I don't know if it sends out emails or not, but even if it doesn't, at least you can go here and double check. All right, so fall 21, pre-calculus. There we go, course announcements. So midterm number 1 will be due at midnight Eastern time. I assume you're all in the Eastern. I mean, yeah, it's an online class, but most of the other classes are probably in person. So nobody's taking this class, for example, from LA. That wasn't necessarily true in the past when these were all pure online classes, but just to be very specific, do it midnight Eastern time on Wednesday, October 20th, okay? That should do it. I'm sure you won't need a week, but you can have it. And remember, try very hard to make a very clear scan or picture of it and send it back to my purchase account. And I'll let you know if there's a problem or if I don't receive it. Because with large documents like this, there's always a chance that it won't get delivered properly. So the problem too is that it doesn't always inform you when there's a problem. If it would come back and say, hey, there's not enough room for this, or, when you send it out and it doesn't go, it should technically inform you that it won't be delivered because of the size of the files, but it doesn't always work. In fact, it often does not work. It just simply fails to send it, and then you never find out about it. So, like I said, you can never overly depend on technology because it's nowhere near as good as we're supposed to think. It fails very regularly, and it always fails at the worst possible moment as well. So, so if I don't see yours in, let's say, my inbox by, let's say, Wednesday, I'll just write to you and say, I don't see it. If you send it to me before, you can resend it. Or maybe we'll put it on Google Docs or something else if the size is the problem. All right. Also, if you do take pictures of it, especially try to make sure that everything is clear and legible, and try to keep it organized as well as you can. Sometimes I get like a bunch of files and they're not in any particular order and they're not labeled properly, and try to be organized. All right, anyway, let's put this up here and we can get back to work. All right, here we go. So a vertical line. Of course, that could mean anywhere along the real number line. So let's say you have something like this. So let's just randomly pick 2 points, 3, 0, and 3, 2. So, and let's say this is x1, y1, and this is x2, y2. So the slope delta y over delta x, which can be written as y2 minus y1 over x2 minus x1. Now, the thing here is that you're going to end up with 0 minus 2 over 3 minus 3. So this is undefined because, of course, we can't have division by 0. So the correct answer is just simply that it's undefined. It's not 0, it's undefined. All right. Now, the equation of a line written in point slope form. Sorry. Now, this is something either you remember or you don't. If you don't remember, you can go look it up. If you go, by the way, if you ever want to look something up, you probably know this. First, you have to have all the slides in front of you, ideally. Sorry. And then you'll look at it and say, well, there's a search mechanism on these PowerPoint slides. So if I were to, for example, open up chapter 1, and said, point, what is this word here again? Point slope form. You should be able to find it. Let's do this. Let's just search for point. Sometimes if you try to do a search engine and you try to be too specific, that makes it harder to find something. Oh, maybe not this time. All right, let's try point slope form. All right, well, you know what that means? It means it's probably in chapter 2. All right, not a problem. We'll just go get it. And we'll try the same search. Well, there you go. And voila, in fact, since it's staring me right in the face, I'm just going to literally copy and paste this. And you can do the same thing too. I mean, if you find it, I mean, you're creating a Word document anyway, probably. Although if you're using a Mac, I don't think it'll be a problem. Even though these slides were all written on a PC, sometimes when you switch back and forth between Macs and PCs, equations can get have strange things happen to them, and so can graphs. But this isn't an equation as such. What I mean is I did not use my equation editor for this. This was typed directly into PowerPoint. The equation editor is this thing down here. And you need it for more advanced cases where there's square roots and that type of thing. So let me see if I can find an example of that. This one right here. This was done with my equation editor. If you try to copy this out of a PC version of PowerPoint into a Mac document, there's a possibility that it won't work. Okay, just be aware of that. You might have to do it by hand. But if not, you can certainly feel free to take advantage of it. Just copy it. I mean, you can handwrite it if you want to, but it's not absolutely necessary. All right, well, with all that being said, let's go on to the next one. What is the complex conjugate of 3 minus 4i? Well, it would just simply be 3 plus 4i. In other words, it's the same numbers, only with the opposite sign. That's what complex conjugates mean. Now look at this one, I to the 7th. Now you can try to figure this one out if you want to. You can write out all the values or powers of I, but it's not absolutely necessary because we did it in chapter 3, I guess it was. Let's go look. This is the one, yeah, I mean, they're all here. And then, you know, obviously it would be nice if you understand it, but as far as the test is concerned, remember, it goes through a cycle. There's only 4 different possible values, minus 1. The I is -1, I squared is, sorry, I is the square root of -1, I squared is -1, I cubed is -I to the 4th is 1, and then it starts all over again. I to the 5th is I to the 6th is -1, and there we go. I to the 7th is -I. And all of this is triggered by the property that squaring I gives us -1. That's why this is happening, okay? So anyway, so the answer turns out to be -I. And for any of the others, you should be able to figure it out, but remembering, like, what if I had said I to the 10th? It's not here, but you can figure it out because it just goes through the same cycle. I to the 9th would be this one. I to the 10th would be this one. I to the 11th is here, and I to the 12th would be here. So you're just adding 4 to this exponent. And then it just goes over and over and over again. It's always the same 4. All right, anyway, with all that being said, how is the axis of symmetry defined for a parabola? Remember what that actually means. If you look at a parabola, it's symmetrical about the axis of symmetry. And we calculate it as x equals minus b over 2a, where, of course, this is based on the equation ax squared plus bx plus c equals 0. Again, if you're not sure, let's see, that should be, where do we find that? Oh, I think we're getting there. Yeah, there it is. It's minus b. Oh, did I miss the negative? No, I got it. X equals negative b over 2a. So it's a vertical line. Okay, x is a constant equal to minus b over 2a. And that's all there is to it. All right, the domain of a quadratic function. So remember, the domain is the set of all numbers that can be substituted into the function without causing either division by zero or a negative square root. So let's see, now somewhere in here there's a discussion about this. Let's just look for it. Oh, here we go. What a lucky break. The domain is all real numbers. Okay, in other words, there is no value of x that would cause either division by zero or negative square root. Because remember, a quadratic function is written as 8x squared plus bx plus c. Okay, now, so here's the domain. The range is a different matter. That depends on the function, but the domain is always going to be negative to positive infinity. Now, for an absolute value function, remember the range is the set of all numbers that, I should say the set of all y values that can be generated by a function. The absolute value function is y equals absolute value of x. Now, what that does is it guarantees that y can never be negative. Okay, y, y can never be negative. So therefore, the range is, as you can probably guess, very simply 0. It can be 0, so we'll use the square brackets for that. But yeah, but it can't be negative. So this is how we'll write it. Okay, and again, if you're not sure, it's in here somewhere. Okay, so either you can find it. Oh, by the way, what's missing here is 3b. It might be in here. Let's see what we can do. No, you know what? Now that I think about it, I think we did this earlier on. This might have been in fact, it might have even been in chapter 1. Here's what we'll do. Now, somewhere in oh, here we go. Finding, I knew it was here somewhere. Finding the domain and range of inverse functions, and then we're going to go, oh, for God's sakes, it's here. We don't want to spend all day looking for it, but it's here. All right, anyway, a one-to-one function. Now, this kind of thing we definitely did in the first chapter. So you have to imagine, like, remember we were drawing these diagrams earlier on in the course. Okay, so in other words, what we're seeing here is that each element in X is associated with exactly one element in Y. So that, let's say, for example, 1 and 2 can't get associated with the same Y. All right, so that's what makes it one-to-one. So that we had an example in here. Let's go back to chapter 1. Okay. So birthdays. Remember we did the birthday example? Birthday is not one-to-one because each person has one birthday, but there's many birthdays that can be associated with different people. In other words, more than one person can have the same birthday. Each person has one birthday, but birthdays can be associated with many people. One-to-one, on the other hand, means each person gets exactly one value and that's it. So social security numbers would be the perfect example of that. Every person has a single social security number, and every social security number is associated with a single person. There's no overlapping. Oh, sorry about that. Okay. So, all right. So anyway, the bottom line is each element in X is associated with exactly one element in Y. That's good enough. Oh, well, actually, no, let's do it this way. And each element in Y is associated with exactly one element in X. So it has to go both ways. Okay, so if you're not sure, as an example, if X contains people and Y contains social security numbers, you don't have to do this, by the way. This is just, I'm just going over it with you. This is a one-to-one function because each person has exactly one social security number. Each social security number is associated with exactly one person, which is not true with birthdays. Just remind yourselves, the opposite would be birthdays. It sounds like it might be one-to-one, but because everyone has one birthday, but the birthdays can be associated with more than one person. So that's the key element here. All right, so by the way, as usual, I'll be posting these solutions on Moodle when we're done, in case you missed something. All right, can we go on? Are we ready? Let's see. I want to make sure that I've highlighted everything properly. Okay, good. But yes, if something got slipped past you, it's you'll be able to download this and read it as much as you need to. All right. Oh, here we go. The domain of the reciprocal. Now, the reciprocal is this one. Y equals 1 over X. So what value do you see here that would not work? Well, if we let X equal 0, then the reciprocal function would be undefined. Therefore, the domain consists of all values of X except for 0. Oh, one more thing. You know what I almost forgot to remind you? Sometimes you can get a helping hand from Symbolab. It does have the capability of helping you with some, not all of this stuff. I'm not so sure about the complex conjugates, but or even the eyes. But for sure, it can help you with the ranges and domains. So why don't we double check that real fast? And since it's free, you can feel free to play around with it all you want. But let's try Y equals I to the 7th power. I'm just curious to see if it can handle that. Oh, there it is. Okay, so it did come back with, what do you know? Negative I. And not only that, but it's explaining it to you. Wow. That's pretty impressive. So there you go. That one is done. How about, it won't be able to handle abstract questions like this one, but y equals absolute x. I bet it can handle this one. Remember, in this case, we just want the range. There it is, 0 up to infinity, including the 0. How do you like that? But remember, you have to be, you have to understand this, just in case the question is worded a little differently, you have to be able to think, oh, and by the way, there should be a graph down here somewhere too. If there isn't, you can ask for one. And you say, oh, that's right, it's this one where it can't go below, y can never be negative. And that way you'll understand it too. You won't just have the answer, you'll understand it. No, won't be able to do this one. Oh, reciprocal, yeah, let's try that one. Uh, 1 over x, come on. Now it's really annoying me now. All right, so we've wanted to tell us, okay, so the range, now this tells me that it includes everything except 0. This is the interval notation we've been using. By having the round parentheses, we're not including the 0. Everything else works, okay? So that's what we will put here. And again, if you're not sure why, let's take a look at the picture. Let's see, where's the graph? There it is. Oh, there you go. Now remember, we're looking for a value of x, which doesn't work. So if you look at the vertical axis, this is x equals 0. And if you notice, the function never quite touches it. It's getting close, but it never quite touches. In fact, we call this an asymptote, a vertical asymptote. The fact that it's an asymptote means that that is not part of the domain. We cannot plug 0 into this formula. Anything else goes. Okay. Now, here's an interesting one. What function has the property that for every x, f of x equals f of negative x? All right, now that one means the function is either odd or even. Why don't we go back to chapter 1? And if you weren't sure, you can feel free. You have a week. You can just flip through the slides until you find what you're looking for. You do have that much time. In fact, we can now go back and investigate 1-to-1 if you want to. But what we're really after is, and I'll just give you a hint, it's either an odd function or an even function. Okay, well then it must be chapter 2. Let's go look at it. Oh, that surprises me. Wait a minute. Maybe it's in 3. I think it's in 1. I don't know what's going on here. There's a huge chart here of domains and ranges for all these different functions that we've been looking at. If you just want to look it up, this is still chapter 1. then our old friend composite functions show up here. All right, let's look at 2 then. Let's see, where's 3A? Wow, I'm getting pretty annoyed here. It's not finding it. Maybe we didn't do that. Oh. Well, if it's not there, it's not there. I'm a little surprised. All right, I'll tell you what, if it's not here, it's not here, then they're not responsible for it. So if that shows up in the test, then we will simply disregard it. I'm kind of surprised. I don't know what that means. Well, we're going to get rid of that one. Very annoying. All right, well, anyway, let's try this one. All right, 2 lines are perpendicular. All right, the relationship, the slopes have a product of -1. That's it. That's what it means to be perpendicular. Now, I know we covered that. All right, let's go look. It has to be here. I don't remember exactly when we did this, but we definitely did it. There we go. Okay. So 2 lines are perpendicular if their product of their slopes is -1. Now, that implies that they have different intercepts. You don't really even need this part, but as long as the product of their slopes is -1, then they're perpendicular. and you know, perpendicular actually means that they're meeting when they cross each other. They're crossing at a right angle. That's what it means to be perpendicular. Okay, now for this one, the range. Now remember, this is a quadratic function. In fact, why don't we go look at Symbolab just to see what it looks like? But we do know it's going to be an upward facing parabola. Let's say it looks like this. I don't know that for a fact, but it's going to have that basic shape. So let's go look at Symbolab. 3x squared. But there's also another way of doing this. You don't have to have Symbolab to do this. There's a formula in here somewhere. 3x squared minus 2x plus 1. So what they're asking for is the range. Now it says right here that it's 2/3 comma infinity, including 2/3. But what we want to do is figure out why. Okay, so there's a technique that we can use for this. All right, let's find it. All right, there's 2. 1. No, you know what? This is not going to work. We need that chart that I had. The annoying thing about the search, this find function, it doesn't always work well with title. Sometimes the answer you need is in the title, and it can't always, for some reason, find it. So I'm going to go back and find that list. And you remember there was a list in here somewhere. And it was just a list. Yeah, I just had it. I think it might have been chapter 2. Oh, no, here it is. Here it is. So what we're going to do is go to this chart, which is, or this section, which is in chapter 1, finding the domain and range of the basic functions. Now, one of these is the quadratic function. Here it is. Oh, see it now. Oh, you know what happened? Let's look at the graph. Yes, you see, there's the problem. This was a bad choice because it doesn't actually cross the vertical axis. So you see what happened? Yes, so in other words, this means you need to find the minimum point. Ooh, all right. So I'll tell you what, let's get rid of this one too, because I just realized this was a very poor choice. It doesn't actually cross. That means the solutions are imaginary. So we don't want that. So I'm going to toss this question too. So, all right, hold on 1 second. So in other words, this requires it to have a real solution, which this one does not. So let's see, what could we have done? Suppose this had been instead -8 or something like that. Okay, now, yeah, all right, I'll tell you, let's just toss this question altogether. And then if it's on the test, I won't count it. All right. So, all right, let's go on to the next section. Now, for each of these, we have to determine if it's a function. Now, how do we do that? Well, what we could do, there's a test. Remember, we had the so-called vertical and horizontal line tests. Okay, let me just check this for vertical line test. This is a test to see if a relation is a function. If a vertical line intersects a graph twice, this means the relation is not a function. Okay, so in other words, if you look at this one, this is a straight line. So if you draw it, this is what it looks like. So if you were to draw a vertical line at any point through this function, it will only cross once. Okay, so for example, let's say I draw it here or here, it doesn't matter. It passes, I guess you could say, vertical line test. In other words, any vertical line will cross this function at exactly one point. Therefore, it is a function. And just in general, any linear equation is a function. Okay, end of story. You don't have to worry about it. As soon as you see that it's a straight line, that guarantees you that it's a function. Unless it's vertical. Oh, I shouldn't. Unless the line is vertical. That's better. All right. Yes, if you have a vertical line, that's different. But for any other linear function, it's guaranteed to be a function. So because no matter where it goes, you can't cross it more than once with a vertical line. All right. Now for these, your best bet is probably to draw a picture. So we did these little diagrams. Whoops, no. Let's go back to black. And just fill in the numbers. Okay, so for the x's, we have 2, 3, -1, and 0. So let's put them in order. -1, 0, 3, and 2. For the range, we have 1, 2, 1, and -2. One, 2, 1, -2. All right, so if you draw the connections between them, 2, 1, 3, 2, -1, 1, 0, -2. So what we're seeing here is that each element of x is associated with exactly one element of y. Therefore, this relation is a function. It's not one-to-one, but it is a function. Okay, so that's what we're hoping to see. Each x is associated with one y and only one y. So on the left-hand side, each of these x's has one line coming out of it, and that's it. All right, now let's go back to the slides for a second. This is all in one, if I remember correctly. Oh, here we go. So a function is defined as a special type of relation that assigns a single value to each element in the domain. No elements can be repeated in their domain, but they can be repeated multiple times in the range. So this is an example of a function. Again, the whole idea is that each x goes with one y, even though they don't have to be in the same order or anything, as long as each x gets exactly one y, just like birthdays. Think of birthdays. Each person has a birthday. And that's a function. Now, this one is not a function because one is associated with two different values of y. It would be like the same person having two different birthdays. Okay, obviously that can't be the case. So, and here's one that's not a function either because one doesn't have a birthday, so to speak. So that's clearly not correct either. Okay, so let's get back to this and we can do the same thing for all of them. And if you draw the picture, you don't have to draw the picture if you're really good at this, but let's find out. How about this one? All right, so let's draw the picture. So the x's are 1, 0, -1, and 1. The y's are 1 and 2. So we have 1, 1, 0, 1, -1, 1, and 1, 2. Here we go. All right, so since 1 is associated with 2 different values of y, this is not a function. Actually, let me write this as x equals 1. That way it's clear that you're taking the x's and associating them with y's. Okay. So hopefully we're getting the hang of this. It's all about how many values is each x associated with. The only acceptable answer is 1. We can't have none and we can't have 2. It has to be 1, just like birthdays. All right, I think that's a great analogy. So if you can remember birthdays, how they work, that will help you figure out whether these are functions or not. All right, so let's try the next one. Let's draw the picture. So for the x's, the possibilities are -2, 0, 1, 0, 1, and 3. On the right-hand side, the y's are 0, -2, 1, and 3. Oh, so they're the same. All right, it doesn't matter. Let's find out. 0 goes with 0. 1 goes with -2. -2 goes with 1. And 3 goes with 3. There you go. The answer is yes this time. Each x is associated with a unique value of y. This is a function. Nice. Okay. Just do it a second. All right. Now we've got to deal with ranges and domains. Well, I'd say these are cases where we can double check our results with Symbolab. So for this one, for example, we've already seen this one. We cannot substitute x 0 into this function. So the domain is all real numbers except for 0. Using the notation we've been using, we can say that the domain is -infinity up to but not including 0, and the union of that with 0 up to but not 0 not including 0 up to infinity. Now the range, if you look at that graph again, just here's what you have to think about for the range. No matter what value, when you substitute into this function, it will never equal 0. So if you think about it, there's no value which we can plug into this formula that will give us a 0. So therefore, the range is also the same. And so what we're going to do is go back and revisit this. We looked at this on Symbolab a little while ago. And we saw that, well, at the time, we were only really interested in the vertical asymptote, but it also had a horizontal asymptote. So in other words, if you see on Symbolab that there's an asymptote, since x equals 0 is a vertical asymptote, zero cannot be part of the domain. And since y, as we'll see in a minute, is a horizontal asymptote, zero cannot be part of the range. So, all right. So the sketch, I'll just try to do a little quick rough sketch of it. It's okay. We saw, this is what we saw in Symbolab. In fact, let's go back and revisit this on Symbolab. Y equals 1 over x. Let's see, here we go. Yep, exactly, right there. You can see not only is there a vertical asymptote, but there's a horizontal asymptote. And so the vertical asymptote means this is not part of the domain. The horizontal asymptote means this is not part of the range. Okay. How about this one? Well, you can see right away there's trouble. All right. If x is less than 2, this will lead to a negative square root. Okay, but x equals 2 is okay. This means that the domain is restricted to all values from 2 to positive infinity. So, in other words, now on the other hand, if x equals 2, y equals 0, for any other value of x, y will be positive. If you look at it carefully, you'll see that that's going to give us a positive number. So in other words, this function looks something like this. So what that means then is that the range is from 0 to positive infinity, including the 0. So we can write it as R equals 0 to infinity. All right, does that make sense? So now if you want to go to Symbolab, and if you look at Symbolab, it might be a little quicker. Let's go take a look. First, let's look at the graph, which is what I showed you. And up here somewhere, yeah, here it is. So the domain is in fact 2 up to infinity, including the 2. And the range is 0 up to infinity, including the 0. And it crosses the axis at 2, 0. As we said, 2, 0 right there. No asymptotes. Oh, I didn't even realize it was doing that. Well, look at this. It was offering to show us the inverse too. How do you like that? I guess these magnifying glasses mean it's offering to give you more details. How do you like that? Man, this thing really has a lot, doesn't it? Why, yes, it does. All right, let's try some more of these. Now, in this case, if we substitute x equals 3, this will give or lead to division by 0. Therefore, the domain consists of all real numbers except 3. All right, so once again, we'll write it out as the domain is everything from negative infinity up to 3, not including 3, and then from 3 up to infinity, not including 3. Sorry, this is negative infinity. All right, so again, what we're really looking for is points that would lead to division by 0 or square root of a negative number. What about the range? Well, again, whenever you have a setup like this, well, I actually think about this. Since x, suppose that x is less than 3. In other words, it's in the first interval. Let's say that x is 2. Then y equals 2 over 2 minus 3, which is 2 over negative 1, which is negative 2. Suppose that x is greater than 3. If x equals 4, for example, y equals 2 over 4 minus 3, 2 over 1, which is 2. So that means that y can be positive or negative, but there is no value of x that would cause or lead to y equals 0. So the range is all real numbers except for 0. So therefore, we write it as also an interval. All right, now, why don't we visit Symbolab and confirm this with the graph? Okay. So we're saying that the domain can have any value except for 3, which implies that that is a vertical asymptote. It can also, the range has every value except 0, which implies that that's a horizontal asymptote. So it's going to, well, all right, well, let's take a look before we try to sketch it. But we do know there are 2 asymptotes. Let's take a look. So let's look at the graph. What do you know? The asymptotes are 0. The horizontal asymptote is 0. The vertical asymptote is 3. So just as we predicted, the range and the domain are such that the domain can have any value but 3, the range any value but 0. Okay, so that takes care of that one. Ooh, the negative cube root. All right, well, what's good about this one is that unlike the square root, any value may be substituted in for x okay, if x is positive, y will be negative. And if you're not sure, for example, the cube root of -8 is -2. If x is negative, y will be positive. For example, the cube root of 8 is 2. And we can have 0 as well. The cube root of 0 is 0. Okay, now what about the y's? So the domain is all real numbers. What about the range? So now the way this thing works, it's kind of hard to visualize it, but y can be, I mean, we basically just proved that not only can we substitute any x into this function, but y can be any positive number, negative number, or 0. Okay. In other words, no matter what you plug in there, you'll be able to get a positive or negative number or 0. And in fact, when we look at Symbolab, we'll see that it looks something like this. So what that means is that because all y's are possible, the range is also negative to positive infinity. All right, now let's confirm this by going to Symbolab. And what you'll see is that all the numbers are possible. Oh, all right. Well, I drew it not well, but there it is. And you can see the domain and the range are both all real numbers. But in our case, at least, we know the logic behind it. So like I said, I mean, it's wonderful to test out Symbolab and all, but you know, you have to understand it too. All right, now we're going to do rates of change. These are easy. We like these because they're easy. Now, if you're not sure where these are found, let's go back to the slides. And I think it's chapter 1. Look for average rate of change. Now, if you can't remember what to call it, just flip to the slides. You know, here, let me show you a quick way of doing this. If you're really lost, you're like, I have no idea where to find this. View slide sorter. You can make this as big or small as you want. And now you can quickly scan through them all without having to flip through every single slide. And you go through and say, when did we do average rates of change? Was that here? Yeah, no, sorry. I don't think so now. Let's go to number 2. View slide sorter. No. How about 3A? How about 3B? Okay, well now, all right, I didn't see it. So let's go back. I thought it was number 1. Maybe I just didn't see it. You know, when you're sliding around like this. By the way, to get out of here, yeah. So let's just use the search engine. Yeah, it was there. I just didn't notice it when I was flipping through it. So this is what you're looking for. In fact, I'm going to copy this into the document. So in other words, what you're doing is this. You've got 2 values for each. This is x1. This is x2. F of x1 in this case would be 6 negative 2 squared, 24. F of x2 is 6, 8 squared, 6 times 64, 384. So the function is telling us, or this formula up here is saying, what you're looking for is f of x2 minus f of x1 over x2 minus x1. So you got 384 minus 24 over 8 minus 2, 360 over 10, 36. Now they're all exactly the same. All right, so you just have to be careful. There's no reason to get any of these wrong. They're all exactly the same, but you have to watch out for those negatives. That's always the holdup, the negatives. That's almost always without fail where people make their mistakes, the negatives. All right, well, if that's the case, then the next one, let me just leave that there so you can still see it. Let's evaluate f of x1. Well, first of all, this is x1, x2. We need f of x1. Now this one's a little messier, as you can see, minus 8 squared over 4 minus 8, 64 over 12. Now we're just going to leave it like that. All right, for now. We're not going to try to convert it into a decimal. Let's just, for the time being, leave it like that. And then we'll simplify later on. Now we need to do the same thing for x2. All right. Everybody's doing okay? All right, good. So then f of x2 is negative 5 squared over 4 minus 5, 25 over 9. Now that's not going to be easy to compare or subtract rather. Well, you'll see, we'll do it. So the formula, remember, would mean we've got 25 ninths minus 64 twelfths over minus 5 minus a minus 8. Ooh, that's pretty ghastly. Now, what do we do about these two fractions? Well, we need clearly a common denominator. Now, there's a lot of possibilities here. Why don't we keep it simple? Actually, let me move this to the next page. So, let's do this. We'll multiply this one by 12 over 12. And then we'll have 64 twelfths times 9 over 9. We're allowed to do that. Negative 5 plus 8 is 3. So what do we have here? 12 times 25 is 300 over 108. 9 times 64 is 576 over 108. Now, here's an interesting side note. This is the equivalent of multiplying by 1/3. Okay, now you can leave it like that. It certainly could be simplified, but it's fine the way it is. I mean, clearly those are both even numbers. If you wanted to get involved with simplifying it all the way to the smallest values, it turns out and I'll just mention this, that you can actually divide the numerator and the denominator by 12. And if you do that, this is as simple as it's going to get. Minus 23 over 27, it looks like. All right, let me just double check that. Yeah, if you divide the numerator and the denominator by 12, it'll come down to negative 23 over 27, but that's not absolutely necessary. This is fine too. All right, now, same thing here. So let me just go copy that formula. So we always have it right in front of us. So once again, this is x1, this is x2. F of x1, 7 plus 4 times minus 3 squared. (43). F of x2, 7 plus 4 times 3 squared. 7 plus 4 times 9. Well, that's interesting. They're both the same. So when we apply our formula, (43) minus 43 over 3 minus a minus 3. Now you're probably wondering, how did this happen? Well, what happened was, this is a parabola. And that means that when, let's see, this would be the first point, minus 343. This is the second point, 343. And so it just so happens that they have the same value of y, which means that the average change between the two is 0, because we're basically going back to the same value of y. So it's a very strange case. It doesn't normally work this way, but here it did. Okay, so the delta y, or the change in y, is 0. Now, why don't we show this up, look at it in Symbolab, and you'll see what I mean. 7 plus 4x squared So we're looking for 3 comma 43. So that, that's going to be way up here. We can't really see it, but yeah, that's going to be awkward, but that's exactly what's happening. So don't be shocked when you see this. I mean, it can happen. It's like being on a roller coaster. Eventually you come back up to that same height. All right, now what about this one? All right, so let me grab the formula again. So we have x1, x2. F of x1 is 5 radical 0 minus 2, 0, which is obviously 0. And f of x2 is 5 radical 5 minus 2 times 5. 5 radical 5 minus 10. So when we plug in these numbers, we'll have 5 radical 5 minus 10 minus 0 all over 5 minus 0. And that one can be easily simplified because they're both obviously multiples of 5. So you end up with radical 5 minus 2. Or a mathematician would say write it as this, but it doesn't matter, obviously. All right, so now you're pretty good at this average rate of change stuff. And again, as always, if you're not sure, if you throw this into Symbolab, I'm not sure how much that's going to help, but you can at least visualize what this graph looks like. I'm sure it's very bizarre. In fact, just because it's so bizarre, let's take a look at it. 5 radical x minus 2x just out of curiosity, I'd like to see what this thing looks like. Oh, it's not quite as weird as I thought. But okay. Yeah, you never know with these functions, I'm telling you. All right, now, here we go. Composite functions. Now, these are easy. All we're doing is adding, subtracting, multiplying, dividing, whatever the case may be. So literally all you have to do is to combine them. X squared, I'll even copy these. So we have x squared. Now I've got minus 3x plus 5 plus x, which means x squared. Now we've got minus 3x plus x that combines into minus 2x plus 5, and you're done. Now, when it comes time to subtracting them, just have to be careful with the parentheses and the negatives. Well, x squared, just copy this. This is something I can't do in a whiteboard, that's for sure. I'm just copying and pasting, but now I have a negative here. So what happens was when I drop those parentheses, I'll have x squared, minus 3x minus 5 minus x. So all of a sudden, I've got x squared. The two x's combined, I've got minus 3x minus x, which makes it minus 4x, and then I have minus 5. All right, now the next one, FG. Now this is, in this particular case, we got lucky because it's just a straight ahead FOIL. Okay, if the expressions were more complicated, well, you know, we could do it. It would just be more work. Okay, so in other words, you're actually doing this. So in order to apply FOIL, we have first, outer, which is x cubed, inner, and last, oops, almost blew it there, minus 3x squared. So again, often the challenge in these cases is the signs. Okay, so again, let's double check. First is x squared times 5. Outer is x squared times x. Inner is minus 3x times 15. Last is minus 3x times x. Okay, now here we only can consolidate two of the terms. We have 5x squared down here. We have minus 3x squared. Then we have x cubed minus 15x. Now we'll consolidate these two. Remember, we'd like to write these in descending order of exponent. So this is the preferred way of writing it. X cubed plus 2x squared minus 15x. And that's it, you're done. All right, now the last one is division. Division normally, there's not a lot you can often do with these to simplify them, I mean. Let me just do this real fast. Okay, so you're gonna end up with x squared minus 3x over 5 plus x. There doesn't appear to be any way of simplifying this, so we could just leave it. Yeah, you can. It's not the case that you can always simplify everything. Here, there's nothing else we can do with this, so we'll just leave it the way it is. All right, we don't need to split anymore. So that's that. Now, this is where it gets a little bit more involved. These are the so-called composite functions. So what happens here? For example, you're taking f of x and you're replacing all the x's with g of x. So we've got 2 g of x squared minus 5. And now you can directly substitute the actual value of g of x. So it's 2 minus 2x plus 7 squared minus 5. Now, this is a golden opportunity for us to do some foiling. So in other words, let's do this. So let's try the FOIL. Here's f. Here's O. Here's I. And here's last. So there's just what's in the parentheses there is 4x squared minus 28x plus 49. So what I'm going to do now is substitute that. So remember, I've got 2 g of x squared minus 5. Okay, so in other words, I took what's in the parentheses and replaced it with this expression. Now all that remains is to multiply by 2 and subtract this 5. And finally, one more step. All right, so that's it right there. All right, now for g of f of x, we are effectively working it backwards. Not really. What you're doing, let's go back. Actually, let me split the screen here. So yeah, so we can see what's going on up here. There it is. Okay. So in other words, what we're going to do is say replace in g of x, replace all x's with f of x. Okay, so that means in this case, now the function is minus 2x plus 7, so you're going to have minus 2 f of x plus 7. So then we actually replace what we're seeing here with f of x, which is up here, 2x squared minus 5 plus 7. So then we have minus 4x squared plus 10 plus 7 minus 4x squared plus 17. And that one was easy. Okay. So just remember what you're doing. All the x's become f of x's. Then the rest is basically careful substitution and some algebra. All right, now the next two are even easier because we're using constants. So what you should do here is first solve for g of 0. So that means since g of x is minus 2x plus 7, that tells us that g of 0 is minus 2 times 0 plus 7, or just 7. So now f of g of 0 is f of 7. And that means replace all x's with 7. All right, so I'm trying to squeeze it all into the screen. It isn't really working. Oh, maybe I can do it. All right, here we go. So since f of x is 2x squared plus minus 5, okay, equals 98 minus 5 equals 93. And that's that. Okay. So then for number 20, we'll do the same thing. The first step should be solve for f of 3. Now, f of x is still right here. Let's copy that. And then this implies that f of 3 equals 3 squared minus 5. 2 times 9 minus 5, 18 minus 5 equals 13. So therefore, for g of x, solve for g of 13, which is negative 2, 13 plus 7, minus 19. Now the next two are the pretty tricky ones. F of f, g of g. But we can handle it. So first of all, remember, this is the same as f of x. It's just notation. F with that little circle f is just shorthand for f of x. So what this means is we will replace all x's in f of x with f of x. That sounds strange. So in other words, since f of x is 2x squared minus 5, f of x equals 2 times f of x squared. Let's hold on. Minus 5. And so now you replace this to have equals 2 times, and then this expression minus 5, which is 4x squared minus 10 minus 5, 4x squared, whoops, minus 15. All right, so that's the final answer. Let me put it down here. Okay. Oh, wait a minute. Oh God, I just realized I goofed it up. I forgot about the square. Ooh, sorry about that. Yes, I just realized it just now. Ah, so I've completely screwed it up. Oh my God. All right, let's take a step back here. It's 2x squared minus 5. And then when you replace that x with 2x squared minus 5, yeah. Because remember what we're doing here. This is f of x. So it has to be 2f of x squared minus 5. All right. So that, ooh, it's a good thing I noticed that. Now, of course, this expression can be calculated with FOIL. So let's do that. Four x to the fourth minus 10x squared minus 10x squared 25 . So now this expression up here can be written as 2 times 4x to the fourth minus 20x squared plus 25 minus 5. Now we've got to multiply everything by that 2 and then subtract the 5. That's the easy part. Okay, and that at long last is the correct value. So yeah, that was the tricky part. Just being careful because I screwed it up. The x is being replaced with f of x, but there's still a square there. So f of x has to be squared with FOIL and then plugged into this expression here. So you've got 2 times that minus 5. And when you drop the parentheses and combine, this is your final answer. All right, now g of g. Now remember, g of g that's how you pronounce it in English. This is g of x. So you're replacing in g of x all x's with g of x. So the function is minus 2x plus 7. This one's going to be much more straightforward because there are no squares. So then you have minus 2x plus 7 plus 7, or x minus 14 plus 7. And you finally end up with 4x minus 7. Okay. By the way, the actual test isn't anywhere near as long as this, I don't think. Well, it's long, but it's not this long. This is like meant to cover a little bit of everything. So don't panic when you see this. The real thing is not quite this long. And plus you have a week. What's good about it though is that, of course, it's all the same stuff. Okay. Now in this next section, we're proving that f of x and g of x are inverses of each other. This is a fairly complex process. Let me just fix that. So I'll tell you what, given how late it's getting, why don't we stop here for a morning break? Because we've got some really tricky stuff coming up. And so why don't we fortify ourselves with some caffeine or something? And then when we get back in about 20 minutes, let's say, we'll be recovered from the trauma of what we've been doing, and we'll be ready to finish this. Okay. And when we're done, of course, you'll be ready to take the test. Okay. So, all right, let's stop right here. I think this is as good a time as any. Okay. All right, here we go. So we're ready to prove that these are inverses of each other. So how does that work? Well, here's what you have to do. To demonstrate that two functions are inverses of each other, it must be true or we must show that, number one, f inverse of x equals x, whoops, and f inverse of f of x also equals x. Okay, so remember f with a little -1 represents f inverse of x. Okay, so we'll start with the first one. So we're being told already that we're told that they are. Okay, so we don't have to worry about proving that they, I mean, we're not saying yes or no. We're saying here's why. Basically, that's what we're doing. So in this first case, we're looking for now, it says here g of x. All right, g of x, f inverse, they will be the same thing. So therefore, for this first case, we have to show that f of g of x equals x and g of f of x equals x. Okay, so because we know that where they're supposed to be inverses of each other, so notationally they mean the same thing. Okay, so we'll start with this one. So of course that x becomes g of x. Now this is where it can get very, very messy. Not necessarily, but it can. Okay, so g of x is in the parentheses. But here you can see that when you drop the parentheses, this isn't so bad. Because look what you end up with. 1 over x, which is the same thing as x. So we've proven half of what we needed to prove. Now, as far as g of f of x goes, we have 1 over f of x plus 4. And f of x, now here's where you have to watch it, is 1 over x minus 4. But algebraically, this is the same thing as x minus 4. And we're done. So remember, 1 over 1/3, for example, is the same as 1 times 3 over 1, which is 3. That's why this is happening. So that one worked out pretty well. It could have been a lot worse. All right, very good. So we have successfully proven that these are inverses of each other. All right, or in this case, we call it f of g of x equals x and g of f of x equals x. And that's what we've done. All right, now if something goes wrong, then you can go back and check your algebra because you've already been told in advance that they are inverses. So this has to work if you do it correctly. Nice. All right, let's try this one. So by now we're getting pretty good at this. F of g of x is 3 times g of x minus 2, or we see that 3's cancel each other out. So we end up with x plus 2 minus 2, which is just x. Excellent. And then for g of f of x, we have f of x plus 2 over 3. All right, because the function is x plus 2 over 3, so we replace the x with f of x. And then, of course, f of x is just 3x minus 2. When you drop the parentheses, we have 3x over 3, which is just x. So we did it. Once again, we've successfully proven that these two functions must be inverses of each other. Now, if you don't believe it, you can go to Symbolab and it'll tell you that, yes, indeed, these are inverses. But here we're being asked to demonstrate it. I don't think Symbolab can do that, but here all we're doing is calculating f of g of x, g of f of x, and making sure they both equal x. And the reason for that is because you're thinking about this as one is essentially offsetting the other. It's like if you take 2, if you square root it and then square it, you'll end up with 2 again. So that's what this is all about. All right, a couple more. So replace the x with g of x. All right, so we have to be careful with this one. The 4's cancel each other out. Or another option here, what we could do is just write it like this. Now, let's not do that. Let's just cancel out the 4's. But we have to watch it with this negative. Okay, this negative is still out here. So we have 4 minus x. And we end up with x. And then, once again, we'll do g of f of x. And that means that you are taking 4 minus f of x over 4. Again, you're just simply replacing all the x's with f of x. And since f of x equals 4 minus 4x, let's drop the parentheses. Oh, sorry, I did the wrong thing. Drop the parentheses by applying the negative. So we end up with these cancel out. We have 4x over 4, and we're finally left with just x. Voila. Okay, so that's that. Now there's just one more. So they're all the same. I mean, you're doing exactly the same thing every time. It's just a question of getting some practice here. All right, one more. Now these look scary, but they're not really. All right, so here, for example, f of g of x is 2 plus 1 over g of x. And again, we have to watch it because here this is actually 1 over x minus 2. Actually, let me neaten that up a bit. And remember, this is the same as x minus 2. 1 over anything is equal to that number. So for any a, I'm just going to note that over here. Just a quick reminder. Therefore, that's why this works, and we end up with x. Nice. All right, and then what about g of f of x? 1 over f of x minus, oh, sorry, I wrote it wrong. It's g of f of x. We have f of x minus 2. Yes, we got a messy one here. But if as long as we're careful, you can see the 2's cancel each other out. So we are left with 1 over x, which we know is x. And we're done. We formally proved it by going both directions, and we proved that f of g of x equals x, g of f of x equals x. That's all we have to do. Okay, here we go. We're going to deal with I. Complex numbers are coming up next. So basically, this is no different than what we've been doing, but you know what I'm going to do? Let's go get our chart. The chart where we looked at all the different i's. All right, that would be 3a, I believe. Right here. Powers of I. This will come in handy, believe me. Okay. And if you want to, I mean, you can go through and confirm them, but if they're here right in front of you, that should make things a little bit easier. So like here, for example, f of 2i minus 7 would be 2 times 2i minus 7 squared plus 3 times 2i minus 7 minus 4. So now we're going to do a FOIL. Let's try that over here. Okay, and so if we apply FOIL to this, first, outer, inner, and last. Now this is where it gets interesting because we have 4i squared minus 28i plus 49, but I squared, if you recall from our chart, is -1. So, oh boy, that does clean things up a little, doesn't it? -4 minus 28i plus 49. And that's what we have here. So this entire expression is -28i plus 45. Actually, let me type that. So we're going to have 2 times -28i plus 45 plus 3, 2i minus 7 minus 4. Actually, all right, I'm going to move this down here. Okay. So let's continue from here. Minus 56i plus 90 plus 6i minus 21 minus 4. So let's see, all the i's add up to minus 50. Yes, minus 56i plus 6i. And then the constants, 90 minus 21 minus 25, minus 4 rather, gives us plus 65. And oh, now something went wrong. No, it didn't. Sorry. Everything's fine. Yes, just for a second, I thought I made a mistake. No, but remember, we often try to write complex numbers with a real number first and the imaginary number second. Not that this one is wrong, but this is probably your best approach right here. Okay, so now the next one should be pretty straightforward because it's just f of I. I like that. So f of I is nothing but I to the 5th minus 2i cubed. So why don't we look at our chart? I to the 5th is I, and I cubed is negative I. But I plus 2i equals 3i. And that's it, you're done. That was nice and easy. Uh-oh, now this next one has a ratio. That could get ugly. Yes, it could get very ugly. So let's see what we can do with it. So I'm using, you notice I'm using the equation editor because this is kind of a mess. Replace all the x's with 6 i's. And down here, okay, so we've done exactly that. All the x's have been correctly replaced with 6i. So algebraically, now 6i, the entire expression squared is 36i squared. Minus 12i, whoops, plus 1. Down here we have 2 minus 30i. Now we're not done yet because we've got that I squared in there. And we know that I squared is negative 1. All right, so here it is. So what I'm going to do is replace that I squared with negative 1. So you've got in the numerator, negative 36 minus 12i plus 1 over 2 minus 30i. And then we can simplify just a little bit more. Okay. So in the numerator, we have, this is negative 36 plus 1 is negative 35. And you know what I'm going to do just to make it a little neater? I'm going to put in the, let's see. Oh no, it's actually fine the way it is, because in both cases I have the constant first, the real number that is, and then I have the imaginary number second, which is the convention that we like to follow. Now, if you want to get super technically crazy with this, in principle, and I'm not going to require this, in math, what we would probably do here is take this one step further and apply the complex conjugate. But I just want to point out, this is absolutely optional. But if you did, you'd have this. You see why this is kind of a headache, because now we have to do two FOILs. But, you know, it's good practice. Minus 70 is first. This is minus 35 times 30. Minus 1050. I, inner, last. Now, of course, that I squared is -1. Okay, so that's the numerator. The denominator, on the other hand, is easy because two of the terms will drop out. So if you try to multiply 2 minus 30i, 2 plus 30i. In fact, it's designed on purpose. The reason why we use the complex conjugate in the first place is a guarantee that the i's will drop out. So I'll have 4 plus 60i minus 60i minus 90i squared. So we'll end up with 4 minus 90i squared. Oh, wait a minute, sorry, this is plus. It's so easy to make mistakes with this stuff. Let's try that again. So we cancel these out. Whoops. 4 minus 90i squared. I squared is -1. Oh, no. I see what I did. Okay. Yes, I completely goofed it up. All right. Now we're talking. So but the bottom line here, we won't do this again. I just wanted to show it to you. This answer here is the same as in the numerator, 430 minus 1074i. And so technically, you know, that would be the preferred form, but you can see what I mean. I wouldn't waste your time. If you get to this point, I would leave it like that. The one on the right is just, it's the same thing expressed a little differently. So just keep that in mind when you're doing this. Now we've got one, oh man, this one looks like a nightmare. All right, and it is, but that's okay, we can do it. Because you're gonna have replacing all the x's with 4i's. Oh my God, there's an x cubed down here. Well, I'll tell you what, I'll try to make sure this kind of thing doesn't happen on the actual test. I didn't realize till now what a mess this is going to be. So, but I mean, we'll do it, but I won't have anything like this on the test. It's just too much, but let's see what happens. That's the numerator. Now, here's what I'd like you to do in the denominator so that we can take advantage of our FOIL. The reason why I wrote it this way is so that this one can be, you can use FOIL on this one. And then when you're done, multiply it by 4i plus 9. So yeah, this is, let's just say this is a very scary one. You can do this, you can do any of them. Okay, now let's do this. Oh, by the way, this I squared is of course -1. So let's at least simplify the numerator. And, you know, of course, you can combine the two constants. Now, what I'd like to do next is the FOIL. So we have 4i plus 9, 4i plus 9. And when I apply FOIL to that, I have 16i squared, 36i, 36i, 81, whoops, 81, not 8i. This is, of course, -1. All right, so we have 65 plus 72i. All right, just double check. Now, if you see in the denominator, this piece is 65 plus 72i. So what we have to do now is this. So let's see, we have 37 plus 8i. So now we have 4i plus 9. (65 plus 72i plus 3. And now we can apply FOIL to this piece. So let's try it. That would be 260i, 288i squared, 9 times 65, which is 585, And 648i. Man, that's a mess. All right, so when you consolidate all that, you get, add these together, you get 908i plus 288i squared plus 585. Now, of course, this one is -1. Okay. 297. Now that has to go back in here. Okay, so finally, we're almost done, believe me. I know it's a nightmare, but 37 plus 8i over this result we just got. And then we still had a 3 up here, remember? Yeah, so we need that. So hopefully this is it. And then one last step. Remember, we want to put it in that special form. All right, let me just go back and double check this. I just want to make sure that everything's in order here. So I said, I definitely will not put one of these on the test. This is too much. Yeah, it looks good. All right. That should do it. It's fine. But one last thing, yes, we want to slightly rearrange it. All right, and that's it. That's fine. Okay, now all of these, well, at least the first 3 appear to be foils, which is fine. We're pretty good at FOIL. We just have to be careful with the exponents, the powers of I. So F 12i O I, and last is negative 8I cubed. So we can consolidate some of these terms. These two, 12 plus 29I squared minus 8I cubed. Now remember, I squared is -1, which implies that I cubed is -I. So we must have 12 minus 29 plus 8I, which is -17 plus 8I. All right, well, that one's nice and straightforward. Okay, so I know, you know what? I just realized I copied something wrong. Oh God. Hold on a second. This is 12I. Nope, this is not right. Sorry. Let's try that again. Yep, that's what I mean. It's so easy to mess this up. I just noticed that there's a 12I here, and I wrote it down as 12. So this is supposed to be 12I. But this part is fine. 12I plus 29 -1 -I. All right, let's try that again. So yeah, okay, this is better. 20I minus 29, much better. Yeah, it's because when I was copying, I did not copy the I, and that's how that happened. So yeah, this is one of the reasons why double checking is a good idea, because it's so easy to make a mistake like that. Okay. So now if we apply FOIL here, F, now this one's really tricky, 12I cubed O is -18I to the 4th. I is -6I to the 4th. And last is 9I to the 5th. So I've got 12I cubed minus 24I to the 4th plus 9I to the 5th. So let's look up some of these powers. 12, now I cubed, we just saw a few minutes ago, is -I. I to the 4th is just 1. And I to the 5th is just I. Okay, you don't have to even look at it, because you can tell if this is 1, this must be I. So that leaves us with -12I minus 24 plus 9I, or -3I minus 24. Okay, now let's apply FOIL here. (16) 8I cubed minus 8I to the 4th. 4I to the 7th. Ooh, the 7th. We haven't seen that in a while. So 8, now remember I cubed is negative I to the 4th is 1. What about I to the 7th? That's negative I. You can kind of tell I cubed and I to the 7th have to be the same because they're 4 apart. Remember, this goes through cycles. Every 4th exponent, we start all over again. Okay, so we've got 16 minus 8i minus 8 minus 4i. So we got 2 constants and 2 i's. 8 minus 12i. Right, let me just double check that. 16 plus 8i cubed. First outer inner is minus 8i to the 4th. Oh, look at this. This one is negative. Sorry. Yep, I knew it. This is actually a negative. This last part, negative 2i to the 4th times 2i cubed is negative 4i to the 7th. So this, we have to change this sign. Okay, so negative makes this positive. See, it's minus 4i to the 7th. Sorry about that. Minus 4 times negative I, which means positive 4i. So this is not minus 12. It's actually minus 4. Okay, so now it's right. Oh, man, all these negatives. All right, now the next one is different. This is a ratio. This one we're going to use the complex conjugate on. It doesn't say that, but that's the kind of the implication. There's nothing else we can really do with it except apply the complex conjugate. So in other words, we don't want to leave it like this because we have an I in the denominator, which is not a crime or anything, but we normally try to avoid that. And of course, in this case, the complex conjugate would be 2 plus 4i. Okay, so remember the complex conjugate. Let's just throw this in here. These are complex conjugates. The only difference between them is the sign of bi, that is. So now, unfortunately, we're going to have 2 FOILs to deal with, but you know what? We're good at this. FOIL is our specialty, as a matter of fact. Yes, it is. You may not immediately say that, but yes, we're very, very good at FOIL now. Let's start with the first one. Six, 12i, 10i, 20i squared. And again, we can simplify this because we know that I squared is -1. And so the numerator is just -14 plus 22i. Now the denominator is 2 minus 4i. This one will definitely simplify. It should end up being a constant. So we have 4, 8i, minus 8i, -16i squared. 4. Now these two cancel, if you notice, which is what we were hoping for. The I squared, of course, is -1. Four plus 16 is, of course, 20. So this is what we're aiming for. So the final result is the ratio of those two numbers. So in other words, we have -14 plus 22i is all divided by 20. All right. Now, let's see. What do we do with this one? Well, we've got a FOIL in the numerator. So let's get that out of the way. (15) minus 10i squared, 3i minus 2i cubed. So we're going to have 15. Now, when we get these two together, we're going to have, wait a minute. I think I wrote something wrong. No, that's right. Let me just double check that real fast. 15 minus 10i squared, 3i minus 2i cubed. Yeah, no, that's it. All right, so we're going to replace some of these. So this one, remember, I cubed from here is -i. So we end up with 25. This is our numerator. Now, in the denominator, we have 1 plus I cubed. So there isn't much we can do with that, except we can make one little simplification. Okay, 25 plus 5i. Now, so we'll put that in the numerator. And in the denominator, we'll note that I, as we saw earlier, I cubed is -i. And that's the end of it. We're done. All right, I think there's only one more of these. Oh, that's good, because yes, I think we had enough imaginary numbers for one day. We need a couple of FOILs here. So for the first one, two minus 4i, 6i minus 12i squared. So we get 2 minus 4i plus 6i. All right. And of course, as usual, I squared is -1, -1. So we should have 2 plus 2i plus 12. So this part is just 14 plus 2i. Now for the denominator, we'll try FOIL on 1 plus 2i, 1 minus 3i. One minus 3i, 2i, minus 6i squared. And of course, that's just -1. So these are the two pieces that we need. So the final result, finally, after all that, is that we're going to rewrite this as the ratio of 7 minus I in the denominator, in the numerator is 14 plus 2i. So for this one, let's not bother with the complex conjugate. We'll just leave it like this, but on the test, you'll not be required. You can leave it like this. All right, now here's something we haven't done in a while, the vertex form. So what exactly is this all about? Now remember, there's two different ways of expressing a polynomial. One is the traditional way, and the other way is to represent it as a vertex, where the vertex is the point h comma k. Where k is f of h, and h is negative b over 2a. So here's what we have to do. We'll start by noting that in this quadratic equation, a is 2, b is -14, c is 8. So h is negative b over 2a, which is -14 over 2 times 2, 14 fourths or 7 halves. K is the f of h, which in this case is 2 times h squared minus 14h plus 8. But now we have to replace this with the 7 halves. So we have 2 7 halves squared minus 14 7 halves plus 8. 7 halves squared is 49 fourths. When you multiply this out, you have 98 fourths minus 98 halves plus 8. Now we can rewrite this as 98 fourths minus 196 fourths plus 8. And this means -96 fourths plus 8. And now 8 could be written as 32 fourths. So you've actually got -64 over 4, which is -16. No. Oh, sorry. No, my fault. It's not. It's you know what I did? I just typed the wrong thing here. This is 98. My fault. 98. So that changes it a little. This is, yeah, oh, that would have been too good to be true. No, we'll just leave it like this, 66 fourths. So therefore, H is 7 halves. K is negative 66 over 4. Or if you want, we can read, I'll tell you what, let's rewrite that to be 33 over 2. 33 over 2. So that way they're consistent with each other. So remember, the form that we need is this. So now we plug some numbers in. Remember, A was 2 from way back here at the top. And then K was 33 halves. Okay. All right, now we're going to go to Symbolab for this one. Just to confirm it, I think it can do this. Let's just go find out. I think it does have this capability. So we started out with 2x squared minus 14x plus 8. So let's see if it has that. Well, it does say the vertex here is 7 halves, comma, negative 33 halves. Well, that's good enough. That just proves that we did it correctly. They didn't actually write it in that form, but we know that we did this right. Well, that's good to know. All right, now how about 38? So A is 3, B is 5, C is negative 9, H is minus B over 2A, that's minus 5 over 2 times 3, minus 5/6. K is f of H. So we'll plug in all the numbers. 3, negative 5/6 squared, plus 5 times negative 5/6, minus 9. Oh, what a mess this is. Oh, God, I almost missed the negative. No, there is no negative because it's squared. Okay, good. All right, so we got 75 over 36 minus 25 over 6 minus 9. So if you want to convert them all into 36, so yeah, for this one, we're multiplying by 6 over 6. This one, we have to multiply by 36 over 6. So we get 324 over 36. Oh, you know what? I just realized I typed this wrong. This is 36. Yeah, okay, that's better. All right, so what do we have here? 75 minus 150 minus 324 minus 399. Wow. Over 36. Or if you can reduce that to minus 133 over 12. So the vertex is minus 5/6 minus 133 over 12. Wow, what a mess. So writing this in vertex form, let me just go copy this real fast. So remember, A was 3, x minus 5/6 squared plus k, which is the same thing as saying minus 133 over 12. So basically we can simplify it as x plus 5/6 squared minus 133 over 12. All right, and again, we can confirm this with Symbolab. So we start out with 3x squared plus 5x minus 9. There it is, minus 5/6 minus 133 over 12. So we're good. All right. Oh, there's 2 more. Okay. Let's get these done. So 2a, h equals minus 1 over 2 times 1, which is, of course, 1/2. K is f of h, which means 1/2 squared minus 1/2 plus 5, 1/4 minus 1/2 plus 5. So let's convert them all into fourths. Let's see, that's going to leave us with 19 over 4. Okay, so the vertex, so to speak, the point, the bottom of the parabola, that is the point h comma k, which equals 1/2 19/4. Okay, but the vertex form is, now a is 1, so we'll just write x minus 1/2 squared plus 19 over 4. Well, that was easy. And again, we'll just double check with Symbolab. X squared minus x plus 5. So we're looking at a vertex of 1/2 and 19/4. Yes, exactly, right there. All right, finally, at long last, this is the last one. And then we have to do some division. Yeah, so we'll have to hustle it up a little bit here. We're running a little short of time, but we can do it. All right. All right, A is -1, B is -8, C is 10, H is -b over 2a, -8 over 2 times -1. So that's 8 over -2, which is -4. K is f of h, which means minus 4 squared, minus 8, -4 plus 10, which is negative 16 plus 32 plus 10 equals 26. So we can say that the vertex, which by the way, this is an upside down parabola. This will be the top. Okay, and then all we have to do is rewrite this in a different form. Okay. So we'll have negative 1 x minus 4 squared plus 26 minus x plus 4 squared plus 26. Okay. All right, that should do it. But once again, we might as well check out Symbolab. Minus 8x squared minus 8x plus 10. What does it look like? Vertex is negative 426, as we predicted. And since this is facing down, that would be the maximum point. All right, quotients, remainders. Now this is long division. Okay, that's really all that it is. It's just that we're doing this algebraically instead of with actual numbers. All right, so this isn't that difficult. It can be a pain, but it's not that difficult conceptually. So we'll start with, let's say, right over here, we have x. We put x right here. So what we're saying is x times x plus 1 is x squared plus x. We're going to subtract this entire expression, and that means we end up with 5x minus 5. So here we'll put plus 5. When we subtract this time, though, we have to, that 5 becomes a negative. So what ends up happening here is that the quotient is x plus 5. Remainder is that negative 10. Okay, now let's see what Symbolab is capable of doing here. I'm very curious to see what it is able to do with this. So x squared, let's try this. Plus 6x minus 5. And then down here, it's x plus 1. All right, let's see what it can do. I'm going to say to it, just solve. Oh, God, now I have to start all over again. X squared, okay, plus 6x minus 5 over x plus 1. Oh my God, here it is. See, now the only problem though is that, well, I mean, if you look at it carefully, you'll see that it's exactly what we did, because we have x plus 5 here. This is the remainder. The negative 10 is the remainder. But the actual result is x plus 5 plus negative 10 over the original denominator, which is x plus 1. If you multiply through here by x plus 1, you'll come back to x squared plus 6x minus 5. So long division right here, oh, here it is again. That negative 10 is the remainder. X plus 5 is the quotient. Okay, they're all done the same way. Now, sometimes the answer is not so neat. And sometimes there's no remainder at all. So we'll start here with, let's say 2x, because I want to multiply this whole thing by 2x. Now I have to subtract, which means this is now negative. Bring this down. And now, oh my God. Well, 28/3 will give me, actually, this should be negative. Wow, this one is terrible. Um, 280/3. Let's see if that divides. No. Yeah, okay, it's a mess. There's no getting around it. Oh my God. Well, I'll try to avoid having such messy ones on the test. These cancel out. This becomes a plus. So you've actually got down here 12 plus 280/3. This is your remainder, by the way. So it's important to get this right. So let's rewrite this as 36/3. 316/3. Okay, great. That's your remainder. And your quotient is up here. All right, let's go back to Symbolab and make sure. (6x² minus 8x plus 12 all over 3x plus 10. All right, let's try that. So we should have, oh, see, they got something a little different. No, they didn't. It's right here. Sorry. 2x minus 28/3. And their quotient is 316/3. Yeah, right there. Okay, we're good. All right, two more. Now, these next two are easy. Passing through a point, 2 points, and linear function. All right, so we're almost done. Two more hard questions and a few easy ones, and we're good. So we'll start with 12x. We have to subtract. And now for this, I want minus 99. But then this becomes positive. So that should be it. Yeah, so here's our quotient. And here's our remainder. All right, once again, I don't want to rush this too much, but we are in a hurry here. So 12x² minus 3x minus 6. Down here we have x plus 8. So we should end up with 12x minus 99 with a remainder of 786. Perfect. Now, by the way, well, I don't know if this is really that helpful. I like the way I'm doing it better, but they have their own approach to this. All right, one more. All right, so we'll need 6x here. So that these cancel out. And then here we'll minus 6. All right, so this is our quotient. This is our remainder. All right, so once again, let's sort into Symbolab. 6x squared plus 12x plus 18. All divided by x plus 3. All right, here we go. So we end up with 6x minus 6 is our quotient, and our remainder is 36. All right. All right, so that was the last of the hard ones. These are easy. Okay, the last few, finding the equation of this one only wants the slope. Well, even easier. Okay, so you're going to have, let's call this x1 and x2. Sorry, x1 and y1, x2 and y2. So m is delta y over delta x. So the difference in the y's is 8 minus 5. Down here we have negative 2 minus 3. So negative 3/5. Now, it doesn't ask you for the equation of this line, but if it did, it wouldn't be that difficult. You would plug it in to the y equals mx plus b formula, and you'd use one of these points to solve for b. Over here, this is good enough. All we need is the slope. And then here's the same thing. Remember this, we can think of this as x1 and y1. So we're going to have 13 minus 5 over 3 minus 0, 8/3. And that's it. We're done. All right. And then I think the next two, okay, these are just written slightly differently. What this means is that x1, y1 is negative 212. That's the only tricky part. The way it's written, it may not be immediately obvious. That's what you're supposed to do. Okay, but once that's done, it's easy. Oh, by the way, in this case, it says define a linear function, so we do need the entire equation. So we've got 8 minus 12 over 5 minus 2. The slope is negative 4/7. So that implies that the equation is y equals negative 4/7 x plus b. And now substitute one of the points to find b. All right. So we're going to have, let's pick the first one. It doesn't matter, negative 212. So this first one is, this is 8/7 plus b. Now, in order to subtract 8/7 from both sides, we have to have a common denominator. So when I subtract, I get 76/7 is b. So the equation is y equals minus 4/7 x plus 76/7. All right, one more. So here, keep in mind, what you're being told is this. All right, so again, the slope will be 20 minus 4 over 10 minus 0. All right, so the slope is 8/5. You can reduce that to 8/5. And now we know that y equals mx plus b. B means, in this case, we already know that this is 8/5 x plus b. So we'll pick the first point, 0,4. All right, and let's see what happens. So y equals 4. And then that means that our final result, wait. Sorry. I did something horribly wrong here. This is supposed to go over here. That's what I get for rushing. Y is 4. There you go. That's more like it. Yeah. Okay. All right. So that means that y 4 equals b. Now we're ready to go. All right. Finally, at long last, y equals 8/5 x plus 4, and we're done. All right, so that was it. So our marathon session is over. If you can put up with that, you can put up with anything. But the bottom line is all the questions on the exam are just like this. So you can double check this when you're working on your exam. You can look at the notes. You can look at the videos. You can play
Hold up, you're uploading this, right?
Oh yeah. Oh no. As soon as we're done, this is going right.
Oh Jesus! I just want to make sure. Thank you.
Yeah. No, that's why I spend so much time doing it in all the details. You know what I mean? I could have just written up a list of answers and it would have helped you not at all.
Yeah.
This is meant to be like, here's all the steps. If you follow these, you'll get all the right answers. So definitely, this is going onto Moodle. Yes, absolutely. So you can read it as many times as you want. Yeah, I would, what would be the point of doing all this and then not putting it on Moodle? That was a lot of work and I don't want it to go to waste. And so this way it's not going to waste. All right. So I'll do that. And then now last night I put the test up there. I mean, I just wanted to make sure it gets up there on time. Remember, you've got a week to do it. Where's Moodle anyway? Hold on. Here it is. All right, this is us. All right. So as a matter of fact, I'm going to do it right now. Now, keep in mind, it is a big, big document. So I hope that won't cause any problems, but so I'm going to save it one more time. It shouldn't be an issue as long as you're not trying to save it, as long as you're just trying to download it or print it, but it is a massive document because all this handwriting and all the equations do take up a lot of space. If worse comes to worse, you can look at it on the I mean, if you click it on Moodle without downloading it, it'll be right on your screen anyway. So let me get that in there. All right, so it's got today's date on it. Editing is on. So you can see right here is the actual test. And, you know, by comparison, it'll be a breeze, I think. I shouldn't say a breeze, but it won't be quite as time consuming, that's for sure. All right, oh, wait a minute. There it is. All right, so there's your solutions. There's your midterm. In fact, why don't we open it up and take a peek at it? Just to avoid any anxiety, any needless anxiety. All right, well, you got your short answers. They're pretty similar.
Wait, you said send the test on your purchase email, right?
Yes, that would be preferred. If you make a mistake,
Gotcha. No, I can do that.
Okay, it's not a big deal. It's just that it's easier for me to keep them all together in one place if you send it to my purchase account. That's the only reason that I asked for that. If you send it to my Gmail, I get a million Gmails every day, and I could lose I could suddenly realize, hey, where is it? It's a lot less likely that I won't be able to see it if it's in my purchase account.
Gotcha.
So, one more thing though, if you notice, some of these are equations. If you open this up in another, let's say on an Apple or on a Mac, and you can't read any of the equations, just let me know and I'll send you a PDF version of it, because that can happen sometimes. So yeah, if you have any issues at all opening it up or reading it or anything like that, in fact, you know what, let me do this. I'll do it right now. Just in the off chance that this happens to you. Let's say you have an older Mac. Oh, wait a minute. No, I can't do that just yet because I haven't turned it into PDF. But if you need oh no, hold on, wait a minute. That's not what I mean. I meant, oh, sorry. No, the midterm is what I was concerned about. There's yeah, let me just put this up there too. Now, you don't need them both. Obviously, one is PDF, one is Word. If you can't read the Word document because you have a Mac, and sometimes it can cause problems with the equations. That's the only reason I'm mentioning this. The PDF version, you'll have no trouble reading it. It's right there. But just to be on the safe side, I'm also enclosing. That doesn't mean you have to do 2 tests. It just means that you can use either version just in case one of them has a problem. Okay, and even then you can just write me an email. So I think we're all done here. Everything's ready. So next week we'll pick up our normal material, which is to say the end of chapter 4. But right now, this is your big focus. All right, so just make sure you understand what we did. If not, you can always send me emails.
Thanks, man.
Sure.
Have a good day.
I have a
All right.
question.
Yes, go ahead.
Do you want us to you want it to be handwritten and then take a picture and
That's
send it
probably your best bet. I really think that's just the only thing I ask is when you do take the pictures, take a look at them, make sure that it's easy to read them. Because sometimes what happens is people don't realize there's glare coming off the paper and that can make it hard to see it. It's not the same thing as taking a picture of your cat, let's say, When you're taking a picture of documents, just be very careful with the lighting. And also make sure it's big enough. You know, if the print is really tiny, I may not be able to read it. So as long as you're careful, the photograph should be enough. The only thing you have to watch out for is they can be very bulky. And if you try to send them to me in a single email, it might refuse to deliver them. So it may be necessary to break them up into different pieces. And if you really and truly can't get it, if like your system just says, no, I won't do this, send me an email and we'll figure out how to do it on Google Docs. Okay.
Okay.
It shouldn't be necessary, but if it is, we'll do it that way. All right.
Thank you.
Now, if you have a scanner, you can use that too. You may have a scanner on your iPhone. There are at least a few good scanner programs. The advantage of those is that the quality is really good. And you may have a physical scanner. If you have a printer, it probably has a scanner as well, which will turn it into PDF, and then you can email it directly to me. So whatever it takes, but I would definitely recommend you do this by hand unless you're extremely skilled within an equation editor, which I don't think that's likely because you probably haven't seen this before. But most likely just do your normal handwriting like you would if you were in a classroom, and then just basically take pictures of everything and send them back to me.
Okay. Thank you.
All right. Okay. Very good. All right. Anything else? Fernando?
In order to get full credit, we need to show every work, right?
Well, let's put it this way. It's not so much that you need to show all the work to get full credit. What happens is if you put the wrong answer down and you've shown all the steps, then I can find what happened and probably give you a lot of partial credits depending on what happened. So think of the writing out all the steps as an insurance policy. If you write the right answer and it's right, I'll give you the points. But if you get the wrong answer, having all your work will give me a chance to give you partial credits.
Oh, okay. So it's more like a suggested backup plan to help you. All right, thank you.
Also, in my opinion, it'll help you reduce errors as well. So in other words, it's really more for your benefit. But I mean, that doesn't mean you have to go absolutely berserk and show every single step and every problem, just the basic outline of what you're doing. Because sometimes what will happen is you go through all these steps and all of a sudden there was a sign error somewhere. And this way I can find your sign error and say, oh, that's all he did. All right, I can take away 1 point instead of 10. So it's really good for you to do it that way, I think.
Okay, thank you.
All right, you're welcome.
Have a good day. Thank you for class, Professor. Bye, everyone.
Anyone else? All right, see you all next time then. And, just don't stress too much. It's exactly what we just did.
Thank you, Professor.
All right, see you later.
Professor, I have it's like a personal. I was yesterday, I saw that you posted it, so I did it because I thought it was due today. Because like I was
Oh,
like
that's-
kind of like freaking out.
Oh,
So like I
you know what?
sent you,
If you
like, the
send it to me
thing.
already and you want to work on it
Can I
some
like
more,
read? Yeah,
all right. You know
can I
what you
like send
do?
you another?
Yes, but you know what I'd like you to do? Send me an email right now and say, by the way, I would like to continue working on my exam.
All right.
That way I've got a written record of it somewhere and I can't forget about this conversation. If I've got, it's in my email, I'll say, oh, that's right. He wanted to send me another one. Okay. Yeah, no, absolutely. You can go ahead and resubmit it when you're truly ready.
Yeah, because I was looking back on it and I saw that I made some mistakes. So
Right. Yeah. No, it was definitely not due today.
yeah, thank you.
All right. But don't forget that email.
I'll send it right now. Thank you,
Okay.
Professor.
Anyone else? Okay, then I'll see you all next time.